Welcome to the workshop. Today we want to take a look at section 4.2, paths and circuits. And in our last video, we took a look at paths, UV paths. The example that we were considering was using a multigraph. So here, for another example, we want to consider just a graph. And this graph we're actually going to obtain by removing the parallel edges and the loops from the graph that we previously used. So let's take a loop at some paths on a graph. So again, by removing the parallel edges, A and J here, and then removing the loop N, we have a graph, no longer a multigraph. Well, I suppose it is still a multigraph. It's just not taking advantage of the parallel edges and loops. All right, so we want to give an example of a UR path that repeats one edge. So we want to work on repeating an edge, and then we want to work on repeating a vertex, just so that way we can get an idea of what it looks like to do such things. We did that a little bit in the last example as well, but we want to focus on that aspect here, so that way we can focus on avoiding these things in our next video. All right, so give an example of a UR path that repeats at least one edge. Now, let's see here. I've got a few ideas here. Let's go up from U to V. Okay, so we'll go up from U to V, and then from V to W, and then from W all the way back down to Y, or down to Y. From Y over to Z, Z up to X, X over to Y. And here, this is where I'm going to repeat an edge, right? I've already visited Y, and now in order to go anywhere else, I've got to repeat an edge. So I'm actually going to repeat the edge here, edge I, go back to Z again, and then head back to R. So I have completed a path that goes to R. So notice here, let's see here, with no parallel edges, paths may be given by just the vertices in the path. So paths may be given by just the vertices in the path. Excellent. So in the graphs that we'll encounter, usually the vertices are labeled, so it makes most sense to give a path in terms of the vertices that are visited, which is perfect. Sometimes edges are labeled, so you're welcome to give paths by the edge labeling as well. But if edges aren't labeled, I would encourage you to just go ahead and use the vertex labelings for describing paths. So here, since we have vertices labeled, we can go ahead and give our path in terms of the vertices which we visited. So we went from U to V, then from V to W, W to Y, Y to Z, there we go. And then up to X, back to Y, to Z again, repeating this edge, and then on to R. That is our UR path. Excellent. If you're curious, here there's an edge between each vertex, of course. That's how we get from one vertex to another, but we can count the length of the path by looking at how many spots between vertices there are. Okay, so in other words, I can go starting here, I can go from one to the next. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got a length of 8 there. Excellent. So let's take a look at another path, but let's look at a path which repeats a vertex but does not actually repeat an edge. So in order to do this, I'm going to have to be able to come into a vertex and leave it and then come into it again and leave it again without repeating any edges. So I've actually have to have at least degree 4 essentially in order to make this happen, unless it's my beginning point or end point. Okay, so my end point only has degree 2, so I'd have to end there. I can't go to R, leave it, and come back without repeating an edge. U, I could leave it, come back to it, and leave it again, so that would be fine. But everything else, most everything else does not have sufficient degree except for X. So we're going to try to travel through X a couple of times. All right, so let's go through X. All right, starting at U, right, because we're working on a UR path, let's go straight away to X. And we're just going to go ahead and pass right through and travel on to Y. And then we're going to go up from Y to W, from W back to X, and from X down to Z, and from Z to R. Excellent. So I've not repeated any edges, but I have repeated one vertex. So I went from U to X, and then from X to Y, from Y to W. Actually, here, let me make sure this is clear a moment. Sometimes the X's and the Y's can get confusing. So U to X, X to Y, Y to W, W back to X. X is the vertex that we are repeating. X to Z, and then Z to R is the path that we have traveled. And this one has a length of, well, there's 1, 2, 3, 4, 5, 6 edges. So this has a length of 6. All right, so next we want to give 2 examples of UR paths that do not repeat an edge or a vertex. Such paths are called simple paths. Simple paths. Oh, there's no T in simple. Simple paths. Excellent. So if we wanted to do this, we certainly can. Let's go ahead and draw some in green. And let's use a little bit brighter green. So starting at U, we could keep things super simple and just go from U to R. Right? Simple path, no vertex repeated, no edge repeated. U, R. Done. Length of 1. Let's see, we could also go from U to, let's see, where do we want to go here? Go from U to X to Y to Z, and then to R. That would work as well. So that has a length of 4. So U to X to Y to Z, and back to R where we want it to go. So in this case, the lengths were 1 and 1, 2, 3, 4. Lengths 1 and 4. All right. So we've investigated paths that repeat edges, paths that repeat vertices, and paths that do not repeat edges or vertices. And what we want to recognize here is that there are, of course, a lot of examples in this graph of simple paths. But if I wanted to travel along the red, right, I could have just skipped going around this triangle, and I could have gone from U to X to Z to R. And by doing so, by skipping over a collection of vertices visited, right, just instead of going around there, around the triangle, I just move on, right? By skipping over those additional vertices, I am observing that that path contains a simple path. So every UV path contains a simple path. All right, so let's observe the actual simple paths from our previous example that are contained in the UV paths. And I could look at the graph for it, kind of like we did for the red path, U to X, skip over the triangle, move on to Z, and then R. So we're just going ahead and skipping over. Well, let me write it out how we're doing it here. For the red path, we had U, X, Y, W, X, Z, and R. So we looked at it on the graph and we said to ourselves, all right, well, I don't need to travel around that triangle. So I'm going to go ahead and instead of moving on from X to go around the triangle, I'm just going to skip the triangle and go straight to Z. So what we're doing is we're removing a sequence from the middle of the path. Okay, so we are removing a sequence. So I'm removing these guys here, gone. Get rid of those. Okay, so our path becomes U, X, Z, R. That is the simple path contained in the red path. Now what about the blue path that we had created? The blue path repeated the edge Y to Z. So we went up to V, over to W, to Y, to Z, up to X, over to Y, back to Z, and finally on to R. Quite a bit going on there. So we had U, V, W, Y, Z, X, Y, repeat the edge from Y to Z, and then finally on to R. And here what we can do is, again, we can look at the graph if we wanted to, or we can simply observe where we are repeating things. So here I go from Y around about and I come back to Y. And I don't want to do that. I don't want to loop around and revisit the same vertex. So I just get rid of everything right there. So now, right, I've gotten rid of the additional vertices that I traveled. I traveled this, again, triangle that was unnecessary. So I move on. Right, skip over the triangle and move on. This brings me to the simple path U, V, W, Y, Z, R. Nothing is repeated now. No vertices, and if no vertices are repeated, certainly no edges are. All right, so that is paths, a little bit more on paths when we're looking at a graph where we can represent a path by a sequence of vertices instead of an alternating sequence of vertices or edges, or as a sequence of edges. All of those are perfectly acceptable options when you're working with a graph. But here we used a sequence of vertices. Additionally, simple path, right, that was the other focus for this section. And we'll move on to a new definition in our next example. So I'll see you guys soon back in the workshop.